I will send. I will send. I have recorded it. I will send it. See. What is Laplace correction for velocity of sound in air? Why it was accepted? What is this equation called as?
Gas constant. Ideal gas constant.
Ideal gas equation.
Sorry, ideal gas equation.
If pressure is constant, then what is that process called? Isobaric. And if volume constant, then isochoric. Temperature constant, then isothermal. And heat constant, then adiabatic. So at isothermal condition, bulk modulus K is equals to atmospheric pressure. Let us check how. PV equals to constant. Is it isothermal? Is it isothermal condition? Isothermal means temperature constant. And at constant temperature, PV will become constant, correct?
Yes, sir.
Now I'm differentiating with respect to temperature. So P dV plus V dP with respect to temperature, this will become 0. So P dV plus V dP is 0. This you know partial derivative. Actually, it is with respect to dt, but throughout dt will get cancelled. Hello?
Yes, sir.
This you know, this formula, what I did?
Yes, sir.
Because if y equals to uv, then dy by dx equals to u dv by dx plus v du by dx, correct? So dx throughout cancel. Same I did, huh? So
Yes.
that means p dv can I write minus v dp. Therefore p is minus v dp upon dv or not? Yes.
Yes, sir.
From this, if I go further, we can say p equals to dp upon dv by v in minus. This whole quantity is called as what? Bulk modulus. So this is called bulk modulus.
Yes, sir.
So whenever atmospheric condition, then pressure is equals to bulk modulus. Copy this much. One more note we see, then we'll write Laplace correction.
Done, sir.
Okay. At adiabatic condition. Adiabatic condition, PV raised to gamma is called constant, where gamma is called adiabatic constant. So now if I differentiate, I will get V. Derivative of V raised to gamma is gamma, V raised to gamma minus 1 dV. We are again differentiating with respect to time, temperature, plus V raised to gamma dP constant is 0. So it will become gamma P V raised to gamma minus 1 dV equals to V raised to gamma dP. So gamma P is V raised to gamma dP upon V raised to gamma minus 1 dV. So gamma P is minus of dP upon dV. This will be V raised to gamma minus gamma plus 1. So gamma P is minus dP upon dV into V. So gamma P is minus dP dV upon V. Therefore, gamma P is bulk modulus. So for atmospheric pressure, bulk modulus is at isothermal condition, bulk modulus is P, and adiabatic bulk modulus is gamma. Complete this much?
Yes, sir.
Now see. What Newton assumed regarding this sound traveling in medium? Isothermal process, or that means slow process or fast process? He suggested that process is slow. Hence, gas gets time to exchange the heat with the surrounding. Laplace suggested that compressions and rarefactions moves very rapidly. Hence, gas does not get time to exchange heat with the surroundings. Thus, the process is adiabatic. At adiabatic process, P equals to bulk modulus K equals to gamma P. Therefore, velocity of sound in air, V equals to root of gamma P by rho, where gamma is Laplace correction, called as adiabatic constant. Please copy this much.
Done, sir.
Gamma is called adiabatic constant. It is given by gamma equals to Cp upon Cv equals to 1.41. Cp comma Cv are specific heat capacities at constant pressure and constant volume respectively. Therefore, at NTP, V equals to root of 1.41 into 0.76, height of mercury 13,600 into 9.8 upon density of air 1.203. This is found to be approximately 331 meter per second. This is in Lowe's agreement with experimentally found value, that is 332 meter per second. Hence, Laplace formula was accepted for air. Right. Done?
Yes, sir.
Okay. So that velocity of sound in air, comma V is proportional to square root of absolute temperature. according to Laplace, V is root of gamma P by rho. By ideal gas equation, PV equals to nRT. So mass upon density is given weight upon molecular weight into RT. So P upon rho, we can write RT by N. So velocity V is gamma RT upon N. Since R, M, gamma are constants, therefore V proportional root of T.
Done, sir.
Okay. Show that pressure has no effect on velocity of sound in air at constant temperature. By Laplace, V is root of gamma P by rho. So V1 upon V2, gamma is constant, V1 upon rho 1 into rho 2 upon gamma V2. Gamma cancel. So V1 upon V2 is root of V1 upon V2 into rho 2 is mass upon volume, volume V2, and rho 1 will become mass, volume will come in the numerator. So V1 upon V2 is P1 V1 upon V2 V2 load. By Boyle's law, P1 V1 equals to P2 V2. at constant temperature. Therefore, V1 upon V2 will be 1. So V1 equals to V2. Yes, please copy, then last time we'll conclude.
Done, sir.
V1 equals to V2. That means initial final is same. This shows that pressure has no effect at constant temperature. Right. Explain effect of humidity. Yes, completed.
Yes.
Suppose we take water in this dish. When it is heated, then water vapors are formed which goes in air.
Yes.
That means, can I say that air drop is this water drop is lighter, therefore it is moving up. Lighter,
Yes.
lighter means density is small. We can say when water boils, then water.
Sir, can you go back for 1 minute?
What you want to say?
Sir, the title, because I was writing the statement.
Explain the effect of humidity. When water boils, then water vapors form, move upwards. This shows that density of this shows that density of water vapor is less then dry air. Since V is root of gamma P by rho, so V is inversely proportional to root of rho. Now, since density of moist air is less than density of dry air, therefore velocity of sound in moist air is greater than velocity of sound in dry air. Right.
Done, sir.
So that when temperature increases by 1 degree Celsius, then velocity increases by 0.61 meter per second. Like this heading. Done.
Yes.
Temperature increases by 1 degree Celsius. We want to find velocity increases by 0.61 or not. Since V is proportional to root of T, let V1, V2 be velocities at 0 degrees Celsius and 1 degree Celsius respectively. Or you can say T degrees Celsius, T plus 1 degree Celsius respectively. Both are same. I have taken 0 and 1 degree. So can I say V1 upon V2 will become root of T1 upon T2. So V1 upon V2 will be T1 273 and this will become 274 in root. Okay. Hello.
Yes, sir.
Copy is not.
Done, sir.
When you cross multiply, then V2 will become V1 into 274 upon 273 raised to half. So V2 is V1 273 plus 1 upon 273 raised to half. So you can write V2 is V1 273 upon 273 1 upon 273 raised to half. So V2 equals to V1 1 plus 1 upon 273 raised to half. So V2 equals to V1. See, I'm using now binomial expansion theorem. By binomial expansion theorem. In maths, you have done?
Yes, sir.
Okay. So by binomial expansion theorem means first term raised to that power. 1 raised to half is 1. Thus it will be half C1 1 raised to half minus 1. Second term 1 upon 273 plus dot dot dot. So V2 will be V1 1 raised to half is 1. Half C1 is half. And half minus 1 is also 1 into 1 273 plus dot dot dot. Dot 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 are higher powers of 1 upon 273. Neglecting terms with higher powers of 1 upon 273 we get. V2 equals to V1 1 plus 1 upon 546. So V2 will become, yes, please copy again this much. Completed till last line?
Yes, sir.
At 0 degrees Celsius, velocity v1 is 332 meter per second. Therefore, v2 is v1 plus 332 upon 546. So this will become v1 plus 0.61. Thus, when temperature is increased by 1 degree Celsius, the velocity increases by 0.61 meter per second. Right. Completed?
Yes, sir.
Okay. Doppler effect. So suppose a train is coming from far distance and you are not able to hear the sound, or somebody is shouting from far, we are not able to hear the sound. तो हम लोग अपना कान के ऊपर हाथ रख लेते हैं ना, ऐसा कर्व करके, कान को क्लोज नहीं करते, कान के साइड में ऐसा कर्व करके हाथ रखते हैं, बराबर?
Yes.
So that person is shouting from far distance, he starts shouting more, he will not shout for more, but whatever waves were getting dissipated in the surrounding, we are collecting them. So that wave gets reflected into our ear so that we can hear clearly. So when train is, this suppose a platform, a train is approaching from here. This is the platform, railway track. If train is moving, the passenger standing over here, when train comes, he feels sound has increased. When train passes away, he feels sound has decreased.
Yes, sir.
This feeling of increase decrease in frequency of sound is called Doppler effect. So whenever there is relative motion between source and listener, whenever there is relative motion between source and listener, then apparent pitch of sound is different than actual pitch of sound. This effect is called as Doppler effect. Right now. Better?
No, sir. Wait a second.
So coming closer or moving away, we feel frequency increases, decreases. That effect is called Doppler effect. Completed?
Yes, sir.
So formula relating apparent and actual frequency. First case, when source is moving, closer to listener. Right, Eddie? Then I'm clearing all.
Done, sir.
Okay. N1 is apparent frequency, N is actual, V is velocity of sound air. When source is coming closer, frequency will increase, so denominator will decrease. We have to adjust denominator. Here N is Actual frequency derivation we don't have. N is actual frequency. N1 equals to apparent frequency. V equals to speed of sound in air. U equals to speed of source. When source moves away, N1 equals to N, N2 equal to N, V upon V plus U. Frequency decreases, therefore denominator increases. So just remember as a note, when source is moving, adjust denominator. Adjusting means increase, decrease depending upon the condition. Coming closer, frequency will increase, denominator will decrease. Moving away, frequency will decrease, therefore denominator will increase.
Done, sir.
Second note, when listener moves, adjust numerator. So our second case, listener is moving towards source. Therefore, apparent frequency is N, V upon U. Frequency increases, so V plus U. Listener is moving away from source. So apparent frequency will decrease. So numerator will decrease. Copy.
Done, sir.
Now theory we have completed full. Numericals. At what temperature velocity becomes double of velocity at room temperature. V is proportional to root of t. Velocity v1 upon v2 is root of t1 upon t2. Velocity becomes double, so v2 is v1. At what temperature? If earlier it was at room temperature. So squaring both sides, we get 1 upon 4 equals to t1 upon t2. Therefore, t2 is 4 times t1. And velocity at room temperature, velocity at NTP. At NTP, this is 273 Kelvin. So 4 into 3, 12, 28, 1, 29, 4 to the 8 to 10, this much Kelvin. Or 1092 minus 273 in degrees Celsius. So 12 minus 3 will be 9, 8 minus 7, 1, 10 minus 2, 8. Write down. For college exam, this is very important sum. At what temperature velocity will become double that at room, that at NTP? Yes, done.
Yes, sir.
So today we stop here. Next class we'll start with MCQ of expansion of solid